Welcome to another video on math problem solving. Today we'll be looking into the negative space problem. So here we go. So we have this figure. Let's read the question. Four squares of side lengths 4, 7, 9 and 10 as indicated in the figure are arranged in increasing order so that the left edges and bottom edges align. The squares alternate in color patterns white, gray respectively as shown in the figure. The question is, what is the area of the visible gray region in square units? What is the ratio of the visible gray to white? Okay, this is within the square though. So how do we go about doing it? So let's take the outer square. We have an inner square of length 9 and an outer square of length 10, and you need to find out the area of the gray square, the gray region. And one way to do that is to break it down into a horizontal rectangle, a vertical rectangle, and a square on the edge. And as you can imagine, it's not very hard to find the area because the rectangle has dimensions of 9 and 1, and therefore the area is 9 times 1. And the vertical rectangle is identical to the horizontal one, which is also 9 and 1, which is 9, and the square has a length of 1, which is 1, and therefore you can add the area of the gray region as 9 plus 9 plus 1, which is 19. This I would call as method 1. There's also another way to do that. You take the same 10 by 10 square and you know that the area is 100. 10 by 10 is 100, but then imagine you cut out, you remove a square of 9 by 9 in this fashion, and what you're left with is the gray area. So in other words, the area of the smaller square is 9 times 9, which is 81, and logically 100 minus 81, the area of the outer square minus the area of the inner square, has to be the answer, which is exactly what we got in the previous one as well. This I would call as method 2. Now why does this matter? Because applying the principle of fluid intelligence, knowing the difference between similarities and similarities between differences, is of paramount importance if you want to be good at math problem solving. So method 1 and method 2 both give you the same answer, but in a different problem, a different situation, in a different context, one method could be vastly superior than the other. For example, let's take the same square, but this time let's carve out a circle with diameter of 9. Now, trying to do with method 1 is going to be next to impossible. It would overly complicate the entire problem and make it almost impossible to solve it. However, applying method 2 becomes very easy because all you need to think about to find the area of the gray region would be, think of the outer square, which is 10 times 10, 100. Think of the diameter, which is 9. The radius therefore has to be half of that. And the area is going to be pi r square, which is going to be 20.25 pi, and therefore the gray area is going to be 100 minus 20.25 pi, which works out to be approximately 36.415 square units. As you can see, much easier to do with method 2. And this method 2 is called the negative space. So you take the whole thing and you carve out a negative space, and what you're left with is the region that you're trying to figure out. Now, we could also extrapolate this into a couple of other problems. For example, instead of one big circle, imagine if I had 3 circles of increasing radius of 1, 2, and 3. What would be the area of the gray square? That's a problem that you can try solving. What is the ratio of the visible gray to white? I'm not solving this problem as yet, but I would love for you to try it out. And if you get the answer, please share the answer and your method in the comment section. Another extrapolation of the same problem could be, I have a square of 10 by 10 and I have a circle carved out with radius 1. The question now is, how many such circles can I fit into this gray square? And if I fit the maximum number of such circles, what would be the area of the visible gray region in that case? This is also a problem that I've not solved here, but I'm just posting it out for you to try and solve, because this is the caliber of Olympiad problems that you need to be solving using the negative space method. Again, if you get the answer, please share your answer and your method in the comments below. Now let's get back to the original problem that we have, which is you have this entire thing, 4, 7, 9, and 10. What is the area of the visible gray region? What is the ratio of the visible gray to white? So let's look at it from just the outer gray region. And you know that it's the outer square minus the inner square. So it's 10 square minus 9 square, which is 100 minus 81. That's 19. The area of the inner gray would be 7 square minus 4 square, which should be 33. 49 minus 16 is 33. The total gray area is going to be 13 plus 13, 19, which is 52, which means the ratio of the gray to white would be 52 by 48. Remember, the entire larger square is 100, so 100 minus 52 is 48. In other words, the ratio is 13 by 12. Now, one of the things I like to do is take a particular problem and extend it and see if we can actually identify other nuances within that. And this is a method which I call as the groundhog method. So in this, we're going to go abstract. Instead of having numbers, what if I had the side lengths to be A, B, C, D? Need not be 4, need not be 7, need not be 9, need not be 10, but A, B, C, D. And they're arranged in the same increasing order. The alignment of the left and bottom edges still hold. The squares still alternate the color pattern between white, gray, white, gray. Now, can you find out what is the area of the visible gray region in square units? And what is the ratio of the visible gray to visible white? This is also a problem which I have not solved, but I'd love for you to solve and share your answer in the comments. And if you'd like me to solve it in a more detailed video, please share that as well. Okay, what are the lessons that we can take from understanding negative space? It's not just limited to visual, geometric, visual kind of math problems. It can also be done in abstract. For example, multiplying 97 times 3 is much easier when you think of 97 as 100 minus 3, because then the answer to 97 times 3 becomes just 100 minus 3 times 3, or 300 minus 9, which is way more easier than trying to do it by directly multiplying with any method. And it's less error prone. The basis of logic and deduction is completely dependent on negative space. If all the choices of a particular problem is removed, then what is left has to be the answer, however improbable. This was made most famous by Arthur Conan Doyle, which I like to call as the Holmes theorem, because this, I think, helped Sherlock Holmes solve so many crimes, which kept us all interested reading through the timeless classics. And if you can remove all your errors and mistakes, what's left has to be a masterpiece. This is a principle that I believe very deeply, and something that I have used to improve my chess in general. Focus on the blunders and errors and mistakes. Try to eliminate those. What is left would be an emergent masterpiece of the game. Another way to look at it is a sculptor just removes what's needed. And that's how he gets the most beautiful statue.